Share my screen. All right, so do you remember what we did last time?
Yeah, we we left on uh, deleting an element from a mutable list, right?
Okay, and what problem did we face last time?
That we can't delete like the first element because then we won't like have the list, right?
Yeah,
The
we can't
same
delete the
list.
first element and also give back the same list,
Right, right.
right? Um, let me first give you a different, so yeah, let me give you a different explanation to this just so just, yeah, okay,
Okay.
hold on, let me pulling out my whiteboard and
Mm,
then I'm gonna share a different screen, share my whiteboard.
okay.
Okay, this was you last time. So I'm going to give you a whiteboard explanation of what's happening. So you have two different explanations. So I give you a theoretical explanation. Now I'm going to give you an explanation that's more related to a model. You know, that box was kind of big.
Mm, okay.
So let's keep it simple. Let's just say we have two items. Okay, so um, the rightmost box, let's call this the empty box. So I'm just going to give it two letters empty. So this is the empty box. So each box, if you remember, there are fields and each field has values. So I'm gonna call it data. I forgot what we called it, but let's just say it's data. And then we have rest,
Yeah.
data, and then rest. And then each field has a box. Okay, so initially, oh, let me connect these boxes. So this rest holds this data and this has this empty. Okay, and
Mm,
let's say if the data is small, it can fit in the box. We can put it inside the box. So let's say first data is one, second data is two.
yeah.
Okay,
Yeah.
so let's say the user passed in users list. Okay, so okay, I'm gonna call it my list. Let's say my list. At first, user has a my list. Okay, and my list points to the first thing here. So let's
Right.
say we are now calling my list the delete zero, delete the first item in my list. Okay, let's say we're calling that now.
Okay.
What depending on your solution, I mean, right now I think the solution doesn't even run. No, I think it does run, but I think it does this. It deletes this arrow, right?
Yeah.
And
Yeah.
it returns the s- the second thing. So return list is something like
Right.
this, right? But
Yeah.
here's the
Yeah.
problem. And let's just say the rest, okay, depends on your solution. I don't know, I forgot what is your solution here, but let's say it links the first one to an empty. Let's say. Technically, this is also not very accurate. Technically, all empties are the same. So technically is this. Technically. It's
Yeah.
the same, and all empties share the
Yeah.
same box. Okay.
Yeah.
So here's the problem. I have my list. I say, okay, I would like you to delete the first element. What does the user get? The user the user gets the complete opposite of what they asked for. Instead of getting the return list, which is two, no, technically they'll get back two, but the list that they mutated, my list is still the first element only. You see
Yeah.
that?
Yeah. It makes sense.
They got the complete, they asked to delete the first element. They got the complete
Yeah.
opposite. They got a list with only the first element. Oh, again, it depends how you do things, but if let's say you call like a return list, let's this Python syntax, okay, like my list dot delete at zero. Let's say you did this, right? They have return list and my list. My list only has the first element, return list has the second element, right?
Yeah. Yeah.
They have two different lists. What is happening, right?
Yeah.
Um, Sometimes this is what you want, but let's say this is not what we want. Let's say we want my list and return list to be the same. Okay? Let's say that's what we
Okay.
want.
Okay. Okay.
So this is a box and arrow diagram of what's happening. Um, and I'm now going to talk about. I'm going to stay on the whiteboard actually. I'm going to talk about how do we address this.
Okay.
If we want my list and return list to be the same, what can we do? So the fundamental problem here is that what's the definition of deleting? So let's say we're trying to delete. Okay, let's say we're trying to delete the second element. Okay, it's actually second element is a lot easier, as we'll
Yeah.
soon see. To delete an element, we take its arrow. This is not a good example. This is not a good example. Sorry, let me add one
Okay.
more. You know why it's not a good example in a moment. Let me add one more thing here. Let's say three.
Yeah, yeah.
Okay, let's say we're trying to delete the second thing. Okay, the one with
Okay.
data two. Here's what we do. First, you take the rest arrow and you point it to whatever the next. Actually, sorry.
We
Sorry,
point
sorry,
it
sorry.
to
Let me
like
reset. Let me talk about that last
okay.
actually. You
Okay.
take the previous box, you take the rest arrow, and
Right.
you do this.
Yeah, yeah.
Now, when you look at my list, oh, first we have data one. We look at the rest. Oh, we have data three. Then we look at empty. This, as far as the box is still there, but as far as my list is concerned, it's gone. You see that?
Yeah,
But
yeah.
but now, we tend to want to do this also. Notice if someone has, um, let's say we have another list that for some reason points to data two. Notice how we will get the same, both my list and another list has the same element three. You see that? They share a box,
Right.
right? When we talk about trees, this will be a very important idea. So I'm going to pause on this idea first. Let's just say we don't want to do this to keep our life simple. Because this means that two lists have the right to change the same element and things could get
Yeah.
messy. Let's just say we don't want this. To make our lives easy, what we can do is we can remove the arrow on data 2 and we make the arrow point to empty. This is what we can do.
Yeah. Right.
In C++ with more memory control, you can just delete the box entirely.
Hmm.
In
Makes
um
sense.
in languages like Pirate, Java, like that are garbage collected, you do not have the ability to specify when to delete a box. You can only
Y-
detach it from all the other boxes and the language will just clean it up later.
Okay. Okay.
So this is like the best you can do. Okay. So what's the takeaway? So we talked a little bit about this last time as well before we left, but it was a bit fast. So I'm giving you the visual explanation. Takeaway: to delete an element, we find the previous element. No, no, sorry, not find. Find has a specific word. We take the previous element. Sorry, my T is a bit broken. And take its next.
You're just spamming these.
Yeah, because like whenever I hit T1, sometimes it shows up multiple times. Like, I need to repair my keyboard and have
Okay.
it point to the currents rest. The English description is a bit messy, but if you look at the diagram, it makes sense, right? We take the previous
Yeah.
arrow, we stretch it to point to the data two's rest arrow, right?
Yeah. Yeah.
Whatever data two rest pointed to just now, data one rest will point to. That's the visual explanation. The English description is a bit messy, that's why I don't like to actually use that. Okay, but what's the problem we have? What's the problem with the first element?
What's the problem with the first element?
Yeah, so let me restore
Mm.
everything now. I'm gonna restore everything. Let's say we have this. If I want to remove data one right now, based on the takeaway, to delete an element, we take the previous element and do stuff with it. What's the problem with data
Oh,
one?
okay, okay. Like So can we like take the arrow that is pointing to the first element? So
Okay.
like the name of our list.
So my list,
Yeah,
what do we
my
do with the
list
arrow?
now points to like the
Like
second
this?
element. Yeah,
Yes, you're not wrong, but I want to bring back to our delete at. So if you consider delete at, so let's say in index, this is like, sorry, let me use pirate. Let me use pirate
of course,
convention
of
to not
course.
confuse us. Let's say delete at, uh, and then index number. My M's also a bit broken. I need to really look at my
You have
keyboard.
to really like loop your keyboard.
I need to pull out all the, so I have an ergonomic keyboard. I need to pull out all the keys and clean it and see if the problem
Okay.
still persists. Yeah, that's what I need to do. I've been procrastinating. Anyway, so delete that index number. We also need to actually take in the list. So let's say M list for mutable list. And let's say delete add has a generic X.
Of course, of course.
We do not see, it's like as someone, as the function that's processing this list, we do not see my list. We only see M list. So So we actually cannot access my list. That's we only see M list. So
Okay.
I've changed the so you're not wrong. But now given this constraint that we cannot see my list, we cannot mess with it, we can only mess with M list. How do we delete data one from my list?
Like change the arrow from my list, like from M list, right?
If we do that,
Yeah.
does M my list change?
Okay, okay, okay. Hmm.
So what's the problem we're facing here? Why can't we like if we wanted to delete data two, it's easy, right? I'm gonna repeat what I did just now. I'm just gonna take the data one
Yeah,
arrow
yeah.
and I'm gonna move it to data three, which is what data two is pointing to, and I change um data two arrow to point to empty, right?
Right,
Problem solved,
yeah.
right? And this my list didn't change, but my list no longer has data two. Why can't we do this? Why can't we apply the same thing to data one?
Because we would like need to change the whole list, right?
Yes, but okay, I want to rephrase that. Why is it that we have to
Okay.
change the whole list?
Mm,
Because there is no previous element.
yeah, yeah. There is no previous. Yeah,
There is no previous element, so I'm going to say prev for prev element for the first item in the list. So the f the fact that the first item doesn't have the previous element is what introduces the asymmetry. So first item is asymmetric yeah, in that sense. You see that?
yeah,
We
yeah,
have to treat the first element differently because it doesn't have a previous element. We call this asymmetric. Symmetry means same.
yeah.
Asymmetric means not same. So data one is not the same as all the other data. It has to be treated differently. In programming, generally speaking, asymmetry is part of life. You can't get away from asymmetry, right? If you want
Yeah.
everything to be same, your program is just going to return the same value. But whenever you have asymmetry, sometimes we don't like that. This is an example of when we don't like that. We're able to delete all the elements except the first one. That is bad asymmetry.
Mm,
Okay?
okay.
All right. Let me ask you, how do we fix this? How can we how can we delete the first element?
Hmm. Uh, like, can we delete it?
Sorry, what?
Can we do it?
Can we do it?
Yeah, is it possible?
It's possible, but you need to change things. What do we change?
Hmm. Can you like change the that the function takes like a reference to the my list?
So let's say we can't do that. Let's say we can't. Is that is actually a valid solution here, but I want to introduce something else. Let's just say we can't do that.
Okay. Hmm. Yeah, I don't really have an idea.
Okay, it's okay. I was just trying to test your brain. So I'll give you uh two solutions that are basically the same. First solution is a bit
Okay.
less elegant, and I'll talk about why is that is. So the key idea here is we need a previous element, and that is a hard fact. We need a previous element.
Yeah.
So,
Can you just like create the first element?
yes.
Really?
So here's what I'm gonna do. This is I'm
I
gonna show
thought
you
about it,
this.
but I thought it like was really stupid.
So I'll show you it's kind of stupid, but this is actually not unusual in C++ programming at least. You have a fake data. So let's say this is zero, okay?
Yeah.
I'm gonna color can I in Excalibur, can I color this, let's say orange? Looks ugly though. Oh, a background maybe blue. Okay. So this um this box the user does not touch.
Okay, okay.
As far as the user is concerned, they do not see this box, but that box is always there, which
Hmm.
means if this whole list has only one element and it's that blue box, as far as the user is concerned, that list is empty. You get what I'm saying?
Oh, okay, okay.
Okay, so mlist now is also going to point to, oh shit. So my list and
Ah,
mlist are going to point to the same thing. Okay, can we delete the first data one now?
yeah, of course, because we can
Okay,
like, yeah, we can change the previous elements rest to the current elements rest. Yeah, yeah.
okay. This Notice how we just introduced this box that contains
Mm,
fake data.
yeah, yeah.
We have a data representation that holds no data. As all right, or holds no information. We have key. We have data representation that holds no information. The only reason why this box exists is for convenience, right?
Okay, okay.
This is a new idea. Everything we've done in the past, everything we created always held information. This is the first time that we've introduced that we
Yeah.
can have things that hold no information. I always hammer this idea. The goal of programming is to convert information to data. Well, it doesn't this betray programming? We're not encoding information. So
Mm,
we are now talking about more algorithms. This is closer to algorithms and data structure. Uh,
okay.
I don't know if you've heard the term. Have you heard the term DSA before?
DSA.
DSA. Have you heard these three
Wait,
letters?
wait. With what? With what?
Sorry, what?
I have like heard it, but
Okay,
wait.
DSA.
Can
I believe it stands for data structure. You know what? Before I tell you what it stands for, let me just make sure that
uh,
I'm right. Give me 1 second. What does DSA stand for? I'm pretty sure it's. Oh wait, in programming. I'm pretty sure it's data structures and algorithm. Let me. Data structure. Okay, I'm correct. Okay, it stands for data
yeah,
structures and
yeah,
algorithms. Programming. When we talk about that, right, we're not just talking about programming for encoding information into data and manipulating data. We're focusing purely on manipulating data. we're focusing on having a model of how things work. We're creating a model, but we also want to think about what this model costs. How expensive does things cost in this model? Okay? We
Okay.
call this a cost model. We don't just have this in
Okay.
programming. For example, if you run a company and you want to estimate how things cost, how much things cost, you also run a cost model. You have a model for how the world works and how much things cost. And based on this model, you can estimate how much things cost. Same thing with programming. We have a
Okay.
model for how much things cost, and we have a model for how things work, and we calculate its cost based on that. Just the cost we experienced just now is asymmetry. I don't want to really talk much about it right now, but let's just say that we are modifying our model for our convenience. We are reducing this abstract cost that is convenience, and we reduce that cost by introducing this empty data representation that holds no information. That's our fake
Okay.
data.
Okay.
But you see what I'm talking about here? The idea that we are
Yeah.
focusing on this model and how this model works, right?
Right. Yeah. Yeah.
Yeah. Okay, anyway, this is a whole new idea. Whole new idea. And this idea only really hmm, I usually pair this idea with mutation. I usually teach this idea of mutation.
Okay.
Because when you introduce mutation, you introduce this idea of box and arrow diagrams, and this box and arrow diagrams is a model. It's a form of modeling.
Yeah.
Okay. All right, I'll leave it at that for now. So this is the one way that we can do this. We have a fake data. In C++, this
Okay.
is not unusual.
Yeah. Yeah.
Uh, but isn't it kind of funny that we have this fake data? Why do we have fake data? Why not just create a whole? So you know how we have empty that holds no data?
Yeah.
So it's sort
Yeah.
of like empty, right? So I'm going to change this box. Oh crap! No, I don't want to delete the box. Oh, like, sorry,
Hmm.
give me 1 second. I just want to delete the things in the box. Okay, then you move
Of
it back.
course.
So we could also have empty, but this empty is not quite empty, you know? Like this empty is a bit different because it has a rest,
Yeah.
right?
Yeah.
It has a rest. So it's not quite empty. Empty isn't quite the word, but it has no data.
Hmm.
So we have a name for this. Sometimes you might hear head. I don't like to call it head.
Has.
I will explain why I don't
Okay.
like it. So it's called head because it's like the head, right? Like right. It's like this is a caterpillar. This is the head of the caterpillar. I don't like to
Okay.
call it this because this sometimes has a lot of meanings. It's not clear.
Yeah.
But typically we also call it sentinel.
Sentinel. Okay.
Sentinel. So in a design of data structures, when you're creating mutable data structures, sentinel is purely for convenience. It holds no data. We will re-explore this idea in the future, but for now, um, I just want you to know that we have a
Hmm.
sentinel. So this is the second way. Instead of having fake data using the same element, we create a new different type of element called a sentinel. It's like a variant of empty, but it has a rest. Okay?
Okay.
All right. Let me think about this. Do I want to go further into this, or do I want to move us to our next topic? Let's go further with this. Okay, I want to talk about the suggestion you made, which is let's say we have a reference to the list that's passed in. For example, in C++, you have a reference, right? Or
Yeah.
you can take the pointer. If you did that, I'm just gonna I'm just gonna write this. I'll just explain a little bit. So let's say like we have pointer to my list. So I'm gonna write in C++ here. If my list equals, let's say my list is not empty, okay?
Okay. Okay.
So let's say my list is not empty. Let's say we did that check already. If my list, if if this is the only element in this list, no, wait, no, wait. Sorry, wait. Sorry. Brain fart. My brain farted. Okay, if index equals 0,
Okay, okay.
Um,
Yeah, it makes more sense, right?
do I want to explain this right now? It's a little bit more complicated than this. Sorry, let me think about how I want to explain this. Hmm. Okay, this is a bit ugly. Let's say we have a boolean that is like that tells you whether or not. Okay, this is a different. Hmm. Yes, this is going to be different from how you solved it. Let's say we always have a previous, except for the first time you call into this function, to this procedure. If previous is now pointed, that means this is the first time we're calling to this procedure, okay?
Okay.
If index is zero and we have no previous, this means that we are trying to cut away the very first element of this list. What we can do is we have my list. Uh, how do I want to do this? I think it needs to be a double pointer. Hmm, might be, this is a bit wrong.
Hmm.
Um, yeah, this is a bit wrong, by the way. Give me one sec. Let me f figure out the rest first. Uh, wait, sorry. This should go here. Otherwise, we do previous rest equals uh
Hmm.
oh yeah, now pointer is
Okay.
empty. So this is like okay, I haven't formally introduced this, so all this I know is like very new stuff, but this is what we'll do in C++. But I want to write the signature first, which is something I should have done first and I didn't, sorry. Let's just
Yeah.
say it's void. Let's say it doesn't return anything.
Okay, okay.
Uh Mutable list. Uh I suspect it needs to be a double point. It needs to be a double point, I'm pretty sure. And then let's say we have int for index, and then we have previous is mutable list. Okay. And so what I wrote here, my list res. I can't do this. I'll have to do this. Sorry, sorry. This was a mistake I made just now. Because my list is a double pointer. What is a double pointer? I know we haven't formally introduced this yet.
It's like a pointer that points to another pointer, right?
Yes. Okay,
Okay.
yeah.
Yeah, like I know the definition, I haven't like used it. It's better to like you use something and not know the definition other than like know the definition and not use it, right?
Yeah. Okay. Okay. Let me move this to the side. You don't actually have to know any of this, but here's what I want to explain. When you have asymmetry, but you want symmetric behavior, you need to compensate for this asymmetry. Okay? What we
Yeah.
did just now with the sentinel, we compensate for the asymmetry by introducing a new data representation with this new box sticking out. the benefit is that now we can treat data one the same as any other boxes, but what's compensating is this introduction of this new thing here, right?
Yeah,
If we go with your reference idea, the idea that we can change, we have access to this my list,
yeah, yeah.
and we can actually change the user's things. How do we compensate for the asymmetry? We need additional ifs, right? We need to check, oh, are you the first element and is there no previous? We need to first identify, is this the very first element, right? You see
Mm,
this?
right. Yeah,
You see
yeah.
that? We compensate for the asymmetry by having an extra if. This, the rest here, like this tool here is the same. This is the same as what we would do anyway with the sentinel. But this is new, right? So whenever you have asymmetry, but you want symmetric behavior, you need to compensate for the asymmetry. We either compensate for it by introducing this new sentinel sticking out, or we have an if. For competitive programming, I don't I don't think you'll get problems like this. I don't think you'll get problems like this. I think this is college level competitive programming. And if you want to get a job in software engineering, at least right now you might get an interview question that looks like this. Sometimes you might prefer, let's say they give you a data definition and it doesn't have the sentinel, and they force you to use the if. Okay? Sometimes you just have
Mm,
to do this. That's just life. Sometimes they might give you, you might have the decision to craft your own data representation and you might decide to have a sentinel. That's something you can do as well. Uh, all this here, you don't have to know the specifics. I just wanted to talk about this if sticking out.
okay, okay.
I think there might be an easier way to actually no, I think this is the simplest this can get. This might be the simplest. Yeah, but when we go into C++, we might introduce this, so I might ask you to write this yourself in the future. So memorize this. No, I'm kidding, I'm kidding, I'm kidding.
Okay,
Okay,
okay. I will just play
uh,
back the video.
play back the video.
Yeah.
Okay, for the remainder of this, I'm gonna ask you to introduce a Sentinel for now, and I want you to get some practice working with a Sentinel, and then we're gonna move on to our next topic. I want to pause after that. I don't want to stay on this for too long just because I want to connect back to competitive programming because right now this is not too relevant for you. But I am
Okay.
showing you this to get you some practice for mutation.
Yeah,
All right. I'm
definitely.
going to let this session expire. I'm going to close this one. I'm going to send you a new link on Zoom,
Mm,
okay?
of course, of
Gmail, okay?
course.
All right. I'll
Yeah.
see you in a minute.
See you in a minute.
All right. So I'm going to give you a list of tasks.
Mm, okay.
Okay. Since I've been writing notes here, so when we have asymmetry, but we want symmetric behavior, we need to compensate for the asymmetry. In our case, we compensate by adding a sentinel. So I'm going to give you a series of tasks now. I don't think we'll complete all of them. Uh,
Mm.
okay, so first task is change mutable list data representation so that it has a sentinel. A sentinel only has a rest.
Mm.
Then create delete at v2 that is able to delete at an index while still returning the same list as the one the user passed in. Okay, you can get started, but I'm going to write some other tasks.
Okay. 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 Uh, sorry, sorry.
Oh, yeah, yeah, it's okay. Yeah,
I'm,
yeah. Add your new
yeah.
lines.
And so, uh, can I like call it mutable list v2 or something? Because I just wanna
Oh, you
make
want to keep
that.
it. Oh, yeah, 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 yeah.
Yeah, yeah. Okay. Sorry. Mm.
Yeah.
I will call it list two.
Sure.
Makes sense. Makes sense.
Yeah.
Thanks. Okay, so it must be. Okay. 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 Uh, it can contain only one. Okay, must contain only one thing, and one thing must be. Hmm. Okay. Okay, makes sense. Uh, of course. What is happening?
Oh wait.
Wait.
I think I'm gonna stop typing. I'll let you type first.
Uh, wait.
My
Okay,
my typing has influenced your typing.
okay.
I'm gonna write my stuff on a separate thing actually, and then I'm just gonna paste it to you.
Okay. Let's copy that. We shouldn't be copying. Of course. List it. No, it's note now. And and this is mm, what can we call it? Like
Oh,
why? And mm, like not note. Mm, is that correct?
interesting. This is actually better than what I expected. Okay, wait. So why did you decide to separate known and mutable list T? Why not combine the two?
Because I thought like mutable list should be a choice, right? Between uh like okay. Uh it should like always point to something, right? But
Okay,
uh it could be like empty or value, right? So the same as mutable list, but we could like we must like add another data, right? So we have like one node and like the word head actually works for me. So like a head of a list. So mhm.
I see. Okay, what you did is actually so okay. Let me first talk about what's the other way to do this, which I think is not as good. So let me. Okay, I'm gonna start typing. Don't type anything.
Okay,
Okay, so node draft one. So okay, this is actually what I expected you to do. You actually surprised me here.
okay. Okay. Yeah,
Um,
it's so easy, right?
and then here we have. I'm gonna you call yours sentinel. I'm gonna call it rest because I called my name of the structure sentinel, so I'll call mine rest. And then node
Yeah.
draft one. So this is what I was expecting you to write. But there's a problem, not to say a problem, but there's a thing that's not so good with this. Do you know what that is?
Uh, that we like always have to separate the sentinel, but we won't like use it every time, right?
Yes, I know what you're saying, but let me reword that. Okay, I'm gonna put this on top. Okay, so okay, yeah. So observations. node draft one. So with node draft one, sentinels can appear in the middle of the list, right?
Right. Yeah.
So as which is not intended. So now we
Yeah,
have
yeah.
to this allows for programmers to make mistakes. Like we intended it to not do that, but let's say another person comes over and like uses your code, right? They may not know that, so they might make a mistake, or you might forget,
Mm.
or sometimes you just make bugs. Sometimes you make a mistake and you suddenly have a sentinel in the middle of your list, and now everything's gonna break. Okay, so
Okay.
remember the idea of asymmetry? This
Like,
introduces asymmetry because
yeah, yeah.
now you always have to check. Wait, is this a sentinel or a link?
Yeah, we shouldn't like allow that, right?
Yeah. So when you introduce asymmetry, you introduce problems, right? We always have to check. We have to compensate for this asymmetry now, so there's more work. Okay, another observation. Oh, I'll tease this a bit. But does the user have any guarantee that their list is well formed? Which is related to the first point, more particularly, also, which is the first point. But I also want to say, is their list guaranteed to start with a sentinel, right?
Hmm. Okay.
Okay, so this is the idea of well-formedness. What well-formed needs, so well-formed means like we want our list to start with sentinel, followed by links, and then empty, right? That
Yeah.
is a well-formed list. But let's say we only have links and an empty, that's not well-formed.
Hmm. Yeah.
So so well-formed is a whole new idea, which we'll get to in the future in more detail. But for now, just know that we have rules to abide by. If our data representation allows us to make things that don't follow the rules, well, shit, we can make mistakes.
Yeah.
Okay, so is that list guaranteed to serve a sentinel? No, right? We can have a link.
Hmm.
Okay, so these are the observations for now. There are more, but okay, keep going. I just wanted to talk about these. What you're doing is great.
Okay, okay. So can I like write the function?
Yes. I would like you to write examples and a template first.
Okay.
So yeah, for a design recipe, I'll allow you to skip the interpretation for now, since I think it's not needed.
Hmm. Okay, okay. Uh, okay. So like function att of course. Why? Uh, like mutable list, list, uh, and numbers return table list, person facts, right? Hmm. Okay, might as well do hmm, a length of uh oh wait, I can just call it three. Um, Okay. So like uh, so okay, so the list should be this was a double and jazz list. Mm-mm. I think what had what they call sen sentinel those. Mm, what is it will be like now it's dot rest should be okay now. Uh okay. Should should I like add more?
Uh,
Uh,
for now, this is good. Uh,
okay.
Typically, I'll ask you to write more tests, just but for time, let's just move on.
Yeah, we only have like 8 minutes. Okay, okay.
Yeah. Oh yeah, you
Uh,
may assume that index is valid. Oh, okay. If index is not valid, just do nothing. Let's just say that. Keep it simple.
okay, okay, okay. Mm, so, okay, okay. Something will be, hmm.
Okay, so what can we do with this? That's not okay. So a bit of terminology, just so I know. Line 483, you have M list and it has a failed sentinel, right?
What? Like,
Line
what line?
483, 483.
Yeah,
So M list structure has the failed sentinel.
right.
So which is the sentinel? Is it M list itself is the sentinel, or is it its field that it's the sentinel?
Mm, so like the fields, right?
Okay, so let's look at your example. So M list 123. You're
Yeah.
saying node 1 is the sentinel. Is that correct?
Okay, okay, okay. Sorry, sorry.
Yeah, a bit of terminology. Yeah, yeah. The structure is correct, but the naming is not.
Okay, okay. So like, hmm.
So let's look at M list 123. Where is the sentinel in that?
Okay, okay. That is not right. So sentinel, sentinel, equals, hmm. Okay. Uh,
So is a link a sentinel?
okay. Is it not? Okay, okay.
So the entire point
Mm,
of introducing a whole new representation is so that a link isn't a
mm.
sentinel, right?
Right, right, right. So it's like, hmm. Uh, wait, wait. Uh, is it not link?
No. Because remember, like if we remember our diagram just now, we have a blue box, right? Link is the white boxes.
Hmm.
So link is the
Yeah,
white boxes. Okay, so
yeah.
remember when we create a new data representation, that new thing was our sentinel, right? What's the new thing here? What's the new thing we created?
Like the
What's our new data
sense,
representation?
like a node, right?
Oh, that's not new. That's the same as before.
Okay, okay.
What
So
what
like this
what's the new
sentinel,
thing?
right?
Uh-huh. Yeah,
Yeah,
can you point to me in the code? What's the new thing to our data representation that we added that didn't exist before in version one?
like this, right?
Uh, sorry, what are you pointing at?
Like,
Yes, 943. So that whole thing is the Sentinel.
hmm.
So your list and the Sentinel are one and the same. You see that?
Okay, okay, okay.
So line 495, Emily's 123, that's your Sentinel, but it's also the list. Okay?
So okay, okay.
So what you did is correct, but the names are wrong. So line 483, um,
Yeah.
should you name the field Sentinel?
Hmm. Okay, okay. So it could be as okay, okay. So it's like the whole list with the sentinel, right?
Uh-huh.
So what should we name it? Hmm. Like that's too much writing, right?
That's a lot of writing.
Yeah.
Well, it's not pointing to a list with Sentinel, it's pointing to a list without Sentinel, right? A node has no Sentinel.
Uh, so can I just call it note?
Sure.
Really?
Yeah, why not? You can name it anything.
Okay, okay.
Personally, I would call it rest. Personally.
Makes sense. Makes sense.
Yeah.
Hmm. Okay. And okay, okay. So do we need yeah, we need a helper function, right? To delete.
Okay, but before you write the helper function, I recommend using it first
Right, right.
to make sure
So
that you are confident on what the signature is.
of course. So
Ah,
we
okay.
have yeah, yeah. And like rest and uh there must be something wrong because oh of course. Uh what was the syntax? Can I use the dots or
Yeah, that's a good question actually. I think exclamation mark is right. Let's try that. Yeah.
with like exclamation marks? Yeah.
Yeah, I think that's fine. Yeah.
Okay, okay. Okay, okay. Uh and there's nothing
Okay.
more to do here, right?
I do have to wrap up here. I got a session
Okay,
to run.
of
Okay.
course.
If you have time, I recommend, if you can work on this. If not, it's okay. We can pick it back up next time.
Okay, okay.
All right. I'll see you tomorrow.
See you
Bye-bye.
tomorrow. Bye.